Hi, this is Mr. Lee. This video deals with the discriminant, so before that, let's just do a simple recap of things. Here we are dealing with a quadratic equation of the form ax squared plus bx plus c equals to 0, from which you can get this entity called the discriminant, which is your b squared minus 4ac. The value of your b squared minus 4ac gives you an idea of what we call the nature of the roots. For instance, if the discriminant is more than 0, you find that there's actually two real and distinct roots to the equation, and graphically you find that the curve actually cuts the x-axis at two distinct points. In the event that the discriminant is equal to 0, then you find that there's actually two real and equal roots, in which case the graph actually cuts the x-axis only at one point. When the discriminant is negative, you find that there's actually no real roots, in which case the graph doesn't touch the x-axis at all. In which case you find that the graph is either entirely above or entirely below the x-axis. Okay, with that, let's take a look at our questions and the solutions. There are two parts to the question today. The first part involves a quadratic equation where you have to show that this curve intersects the x-axis at two distinct points. So once you see that a curve the curve cuts x-axis at 2 points, you find this is where you have to show that the discriminant is more than 0. So of course, if you look at our ingredients, right, our ax squared plus bx plus c, our a, right, the coefficient of x squared here is a 1, b is 2a, and c is 2a minus 5. So just put together and you form the discriminant from here. Here you find that you end up getting a quadratic expression in terms of a. And as with any good algebra practice, right, do take out any factors in common. In this case, 4 is a common factor. So your job is to show that this expression is positive. So we first analyze what happens inside the bracket, right? This a squared minus 2a plus 5. So the trick over here is to show that this quadratic expression is positive. And one way to do that is to actually do the complete the square. So here you actually isolate a squared minus 2a, and then you go through the usual ritual to complete the square. Our subsequent videos will actually do a little bit more on that, so do look out for it if you need more practice on that. Okay, so in completing the square, you find that the a squared term and the a term basically simplifies to a minus 1 squared minus 1 squared. Right? If you recall the process where you need to divide the coefficients of your a by 2. Okay, and then after that, of course, you find that you simplify to a squared term, a minus 1 squared plus a 4. And of course, since a minus 1 squared is always at least 0, you plus 4, right? This is certainly going to be at least 4. Point over here is that entirely this quadratic expression is more than 0. Okay, so of course that means that 4 times of this quadratic expression, which is the discriminant, is also more than 0, which is essentially what you need to show for the question. So conclusion is that the quadratic equation has actually two real and distinct roots, and hence the curve actually cuts the x-axis at two distinct points. Okay, that is for the first part. Part B deals with a slightly different kind of setup. Now instead of one quadratic graph, you are given a curve and a line. Okay, and what is of interest over here is to know when the line does not cut the curve at all. Okay, so idea is this, right? Whatever it is, you have a line and a curve. You first group the two guys together, equate them, and you find that what happens over here is you want the line and the curve equation, this equation to have no real roots. With that, you can get a quadratic equation in terms of x. Okay, just shift everything to one side so that you have 0 on the right hand side. So this is actually where we link it back to the discriminant, because for this quadratic equation to have no real roots, the discriminant here must be less than 0. So here if you look at the terms, they are highlighted in different colors. Your a is 3, your b is m, your c is negative 2m. With that, you can get the quadratic discriminant over here. And you want it to be less than 0, right? That's the criteria for no real roots. So this ends up having you to solve a quadratic equation in terms of m. So the trick over here is to factorize out the m. And as with any solving of quadratic inequalities, strongly advise that you actually draw the quadratic graph in terms of m here. So find where the graph cuts the x-axis, in this case negative 24 and 0. It's a U shape, so the graph looks something like this. Okay, and here you want the region for which the U shape is actually below the x-axis, and that means that from here you see that m is between -24 to 0. Okay, our next few videos will touch more on computing a square and solving of quadratic inequalities. So do stay tuned and see you in our next video.